Hi, my name is Valerie Flynn, and today I'm going to be separating light into colors using water. Now, the way we perceive the physical world is dictated entirely by the interaction of light and matter. Now, the light that enters our eyes produces these images due to this interaction. Now, the incident light on the surface of the liquid, in this case, it will be equal to the reflected ray and also partially refracted. Now, the law of reflection, as stated in our current textbook, Conceptual Physical Science, on page 260, reads the angle of reflection equals the angle of incidence. Now, I'm going to conduct two experiments. We're going to show the spectrum of color created on water using two different mediums. We'll be using tepid water in glass bowls. One bowl will contain drops of clear nail polish, roughly 7-8 drops. Big bowl, lots of water. Second bowl, I put just enough vegetable oil in it to cover the majority of the surface of the water. Now, the intensity of the colors are going to depend on the angle that it's viewed at, so I'm going to use a focused light, probably at some point here, to help describe exactly what I'm looking at, what I see, and what the differences are between the two. Now, we look at the water with the nail polish, and I can see, let me bring this down. What I see are fractured objects with multiple colors of the rainbow. We've got reds, purples, greens, kind of like a fractal. Very colorful, very pretty. Not so much in the rainbow form, but all the colors are there. Now, in this bowl, we have the vegetable oil, and it comes up to almost about a half an inch from the outside perimeter of where the water is in the bowl. Now, maybe it's because it's vegetable oil. It does not seem to give up nearly as much as the nail polish. I am able to create a rainbow here of color, but it is not nearly as powerful as what I see coming through from the nail polish side. Now, as we look at the water, we can see that the light reflects from the surface. The reflected rays from the light, my flashlight, must overlap as it leaves the surface of the film on both bowls so that the colors can be seen. Now, the colors appearing on the oily surface is called interference. The rule is light passes through glass and water without absorption. Now, that would indicate that the index of refraction of the oil is greater than that of the water alone. This means that the speed at which the light enters the medium, in this case the water, is faster than light penetrating the vegetable oil. Now, the colors seen on either surface is called a spectrum. Now, a spectrum is defined per Answers.com as the distribution of energy emitted by a radiant source, say an incandescent light, arranged in the order of wavelengths, which is why when we see the colors in either bowl, lots of color. Now, this is why we observe a rainbow. They're colors that can be seen by the human eye. So from this experiment, we have observed the law of reflection, incidence, index of refraction, absorption, and interference. So next time you see a rainbow, remember, you're not seeing all the colors, just a lot of them.